This assessment asks us to show the mechanism of 4 reactions in the catalytic cycle shown here on the right. The purpose of this exercise, in addition to reminding us of the mechanism of a new reaction and 3 reactions we've seen before, the other part is to take this complicated catalytic cycle that may look somewhat intimidating and show that it's nothing we haven't seen before. And so the reaction starts here. Instead of using a per acid, a per carboxylic acid, it uses this per sulfonic acid. And yet our mechanism that we're going to draw is going to be pretty similar to what we do with MCPBA. And so that reaction is going to start by the pi electrons attacking this oxygen. That's going to help this oxygen-oxygen bond break. These electrons are going to go over here, pushing a pair of pi electrons out to remove that proton and return these electrons to oxygen. Now, why do the electrons need to return to that oxygen? Right now it's neutral. Well, at some point in the mechanism, it's going to generate a partial positive charge because this lone pair adds back to that carbon. And so this is reminiscent of that butterfly transition state that we saw with MCPBA. We end up with this epoxide. In reaction 2 here, we're taking this epoxide and simply protonating it. So this is just an acid-base reaction. And when we see it in the catalytic cycle, we might get intimidated, we might miss that, but by separating it out, we realize that this mechanism is as simple as the epoxide oxygen grabbing a proton from the acid. At this point, we have a protonated epoxide. We've seen protonated epoxides get opened before, so we're going to open it with water. So our water molecule is added to this carbon. Water attacks, pushes these electrons up here. Why did it attack this side? We're not worried about that in this case, but what we can comment on is since the protonated epoxide is on the top face of the molecule, water is going to add from the back. And then finally, we go from this protonated alcohol. We say often that water brought along its proton, so now has a positive charge. In the final step, we'll do another acid-base reaction to give us the transdiol product. Once again, in addition to seeing the mechanisms of these 3 old reactions and 1 kind of new reaction, this shows us that by simplifying, by breaking apart these complicated processes into their individual steps, shows us that we know quite a bit more than we might think we do.